Good morning. I am Mansi Ghare. Today I am going to explain you the difference between type 1 superconductors and type 2 superconductors. Before that, we will see what is meant by superconductors and what is Meissner effect. Superconductors. Superconductors are materials that conduct electricity with zero resistance below a critical temperature, that is Tc. Two types based on their magnetic behavior are type 1 superconductors and type 2 superconductors. The materials under the superconductivity state are called as superconductors. The temperature at which a normal material transforms into superconductor is called the transition or critical temperature Tc. The minimum field required to destroy the superconducting state is called as critical magnetic field. Masonry effect. The Masonry effect is a fundamental property of superconductors. It refers to the complete exclusion of magnetic field from the interior of material when it becomes superconducting below a certain temperature. Now see the figure. When temperature is greater than critical temperature, the magnetic fields lines passes through the material, and in figure B, when temperature is less than critical temperature, magnetic field lines are pushed out the material. This is Masonry effect. Now let us see the difference between type 1 and type 2 superconductors. In type 1 superconductors, the material loses magnetization suddenly because applied magnetic field reaches a single critical value called the magnetic field Hc1, and they exhibit complete Masonry effect because in superconductivity complete magnetization is happened, and the Hc value is too low, that is 0.1 Tesla. There no mixed state exists, and in type 2 semiconductors there exists two magnetic field, that is Hc1 and Hc2, so that is why it is called as mixed state. These are called soft superconductors because the value is too low, that is 0.1 Tesla, and it requires low magnetic field to destroy superconductivity. Example: Ai, aluminum and zinc. In type 2 superconductors, the material loses gradually because they allow partial penetration, as in the type 1 superconductors the materials loses gradually suddenly, and in type 2 semiconductors there are two critical magnetic field values. They do not exhibit complete Masonry effect because there is no magnetization completely happened. There are two magnetic fields, that is Hc1 and Hc2. The Hc value is that high, that is 30 Tesla. Mixed state exists, as I have told you above. These are called hard superconductors because very strong magnetic fields passes without losing the superconducting properties, and it requires high magnetic field to destroy superconductivity. Example: yttrium, barium, copper oxide. Thank you.